Today, we're going to be going over L'Hopital's rule. So say that you're trying to find the limit as x approaches k of f of x over h of x, and you get 0 over 0, or you get plus or minus infinity over plus or minus infinity. It doesn't matter what the signs are so long as they're both infinity. So if you get 0 over 0, you get plus or minus infinity over plus or minus infinity. Then you can just take the derivative of the top and the bottom separately. Then you divide and then plug in. So this is what it would look like. You take the derivative and take the derivatives and divide the numerator by the denominator. And if both the numerator and the denominator are both still 0, or they're both they're both infinities, then you can try out L'Hopital's rule again. Otherwise, you've arrived at your final answer. So important thing to note, it does not work if the fraction stops having the form of 0 over 0 or plus or minus infinity over plus or minus infinity. So if it stops having this form, then you've arrived at your final answer. L'Hopital's rule only works under very strict conditions, so be careful of that. So here are some times when you can and can't use L'Hopital's rule. So if you have a form of 0 over 0, or positive infinity over positive infinity, or negative infinity over negative infinity, or negative infinity over positive infinity, or positive infinity over, I didn't write it here, but if you get positive infinity over negative infinity, yeah, for all of those conditions, you can use L'Hopital's rule. However, you cannot use L'Hopital's rule for something like 0 over infinity, or negative infinity over 0, or 5 over 0. In that case, L'Hopital's rule will not work. So if you try using L'Hopital's rule, you might get a wrong answer. So yeah, only use L'Hopital's rule when you've met the conditions. So let's look at an example. And so for this problem, I want you to try to decide whether or not you can even use L'Hopital's rule. If you can, and yeah, if it's going to be helpful for you to use L'Hopital's rule, then use it. Otherwise, don't use it. So please pause the video and try it out on your own. Alrighty, so turns out you don't need to use L'Hopital's rule. You can just plug right in, and the reason why, if you just plug in 4, you get 4 over 32, and that's just going to be equal to 1/8. You didn't need to use L'Hopital's rule, and besides, you didn't even meet the conditions for L'Hopital's rule. You didn't get, remember, the conditions were either a 0 over 0 or plus or minus infinity over plus or minus infinity. So we didn't meet that condition here, and so we couldn't have used L'Hopital's rule. So yeah, we could not have used L'Hopital's rule right here. Let's move on to the next problem. Find the limit as x approaches 10 of x minus 10 over 2x squared minus x minus 190. So try this out on your own, see if you can use L'Hopital's rule. Yeah, just make sure that the conditions are satisfied before you use L'Hopital's rule. And if they're not satisfied, don't use L'Hopital's rule. So go and try out the problem on your own. Alright, so if you plug in 10 for x, you're going to get 0 over 0. And so for this we can use L'Hopital's rule. So we get, let's see, the derivative of the numerator and the denominator, we get 1 over 4x minus 1. Then we try plugging in 10 for x again, and we get 1 over 39. And so that's the answer. That's our limit. And then for our last example problem of today, find the limit as x approaches 0 of 2x squared plus x over 4 times x to the third power. So please pause the video and try it out. Alright, so if you plug in for 0, you get 0 over 0. So this means that we can use L'Hopital's rule. Plug in, you get 4x plus 1 over 12x squared. Then plug in 0, and then you'll end up with 1 over 0, which means the limit does not exist. And yeah, so the limit doesn't exist, and that's our final answer. You can't, like, it's not like you can try using L'Hopital's rule again, and hopefully get a real number solution as your limit. That's not going to work, because look here, we got 1 over 0. So our top is, like, we don't have the forms as discussed previously. We don't have a 0 over 0 here, or we also don't have a sort of infinity over infinity. And so yeah, we can't try applying L'Hopital's rule again, and so does not exist. The limit does not exist. That's our final answer. So thank you for watching, and I hope to see you back soon.